Hello, dear friends. In this session, we are going to discuss about exploratory data analysis. We can call it as EDA. The main purpose of this EDA is to get the in-depth about the data. So in data science, the purpose is to find the insight of the data, to get the knowledge about the data. So using this data, the machine learning algorithm will be start learning the data. So this data plays a major role in taking decisions, identifying patterns, and also to do better decisions. So if this data is not proper, then the results we obtain through the machine learning algorithms or the model which we create will not be good. So it is more important to give a proper input to this machine learning algorithms. The purpose is to make a better decision, to get good patterns, and also to do the predictive analysis. So here using this EDA, we can able to make the data proper. So what are the things we can able to do with this EDAs? We can able to understand the data. We'll get the in-depth about the data because the data may be collected through any source. So it may be, but if we don't know how well the data is, so we have to understand. We want to know which are all the important features, which is not important. So we have to have a proper understanding about the data. So EDA help us in that manner, and also it will also help us to know the characteristics of the data, and also we can visualize it through the many tools available in Python. We have Matplotlib and Pandas are there. So this all will help us to do that. And finally, once we understand and we find the characteristics about the data, then we can able to clean the data, and by which we can remove the unwanted data which may affect the future results. So these are all the things we can able to do through this exploratory data analysis. So for this, I have used a data set called house price. This is the data set which help us to find the predict the price. By seeing all this feature, we can able to predict the price. So it says about the many features about the house. So this data we are going to see, and what are the features available here in this data set is date, price, bedrooms, bathrooms, square feet of the living room, and many more you can see here. So this data we are going to take and we are going to do EDA on it. So for that purpose, first I am going to import the library called pandas. We know the purpose of this pandas. It will help us to do all the functionality with the data frame. So for that, first I am going to import this library, import pandas PD, and using this PD, this panda libraries alias, I am going to read the data set. Okay, and it is my data set is in the form of CSV file. So I'm going to use read underscore CSV, which is inside this pandas library. And the name of my data set is house price my .csv. And now let us run this one by one. And here I'm going to run it so that this is my data set. So the data set is imported and it is converted to a data frame, and it is available in an object DF, and these are all the different features of my data set. Now let us understand more about this data by using many of the properties available inside this Panda library. Okay, so here you can see many rows are available. It is from 0 to 23. So totally 24 rows are available. So if I run this shape property, okay, df is the data frame dot shape will help me to find the number of rows and columns available. So 24 rows are there and 16 columns are there, which speaks about the features of this data set. And then this is one feature. Similarly, we can also find the size. There is a property called size. So this property will help me to find total number of values present inside my data set. So there are 384 data available. And also we have some other features called info. So what is the purpose of this info is it will give me lot of information about my data frame. So here it is displaying about all my features available in my data frame and how many not null values are there. You can see there are 24 rows. In each feature, how many not null values. So in date, all are not null values, but in place there are two null values, and in bedrooms all are not null values. And by seeing this you can see here there are two null values, here there is one null value. So how many not null values are available and what are the data types of each and every features of my data set is also displayed. So this info will help us to give the information about the data set. And also we also have another function called describe. So this describe function will help us to know the statistical information about my data set. So what are the statistical information for each features? Okay, for all the non-categorical data, we can able to found what is the count, what is the mean, what is the standard deviation, what is the minimum value, maximum value, what is the 25% of that particular value, 50%, 75%. All these things are the statistical data. So using which we can able to find all this information. So to understand the data, so this properties and the function which is present inside my data set will help me to do that. So then also after that, we want to, after we analyze and we go through all this, we can also do some more functionalities here. If I see my data here, we can see here, you can see clearly some of the features. You see date. Here you can see all the data same. So there is no use of having this feature date. And if you see this feature waterfront, all the values are 0. So this doesn't give me any insight from this data. And if you see also this column, this feature is also full of zeros. So this is also not going to give me any information about this data, or I will not get any knowledge out of it. So these things can be removed. So how can I remove this? So using this drop function, I can able to remove it. So df is the data frame dot drop. Now I'm going to give which are the columns to be deleted. So here I'm going to delete waterfront, view, and date. So which I feel which is not important, so I'm going to remove it. And since I'm going to remove the column, in this axis property, I have to give 1. If I want to remove the rows, I have to give 0. Since I'm going to remove the total column, I have to give here 1. And then in place equal to true. So this property helped me to reflect the change in the original data frame. If I don't use in place equal to true, or if I use in place as false, the column drop will not be reflected in the original data frame. So for that purpose, we are dropping. Let us execute it. After I drop, if I run it, you can see initially there are how many columns are there in my data frame. Initially there are, before I delete in my data, we can see what is the shape. So if I see the shape, initially there are 24 rows and 13 columns. No, after drop. Okay, let us execute it. And then if I see this shape, initially we can see there are 16 columns are there. 16 columns, totally 16 features are there. So now we are going to delete it. After I delete it, if I run it, you can see there is only 13 columns. Why? Because 3 columns we have dropped. So this drop helps us to remove the unwanted columns from our data frame. Okay, the next is if you want to display it and see, you can see the date column is not there, and water friend this columns which we deleted is not there, and it is also reflected in our original data frame. Okay, so the next is we can also drop the duplicate rows. So for example, if we see in our data set, many of the rows are duplicated. So here you can see this two rows are having the same values, right? So, and if you see in some other places also, and also if you see here, this two also have almost same values. So what can I do? The rows which are duplicated can be deleted. Also, I have an option. I can see only the particular column, and in that column, if there is anything duplicate, that also I can delete. First, let us delete by seeing a particular column. For example, if you see in bathroom, this feature, see this value is duplicated, and they here also 2.5, here is also 2.5, here is also 2.5. So many in this we have many values which is duplicated, which is coming again and again. So what can I do? I can remove those things. So for that, we have function called drop duplicates, and I'm going to say in the subset which column I have to particularly see and I have to drop. And also I have another property called keep that help me to say that you keep alone the first value and remaining you delete. For example, here 2.5, 2.5, both are the duplicate values. So I'm saying keep the first value and remove the following. After that, if I find any 2.25, you drop those things. And if you see here, here also 2.5, here also 2.5 is there. So if I say keep equal to first, it will keep this first find value, and the remaining 2.5 will be deleted. So that is what. Here we can also give last also. Instead of first, we can also give last. So if so, the last value will be kept and the remaining duplicated value will be deleted. So now if I run this, you can see here in my data frame, we are looking at the column bathroom. That is a subset. Only in that particular column, I'm going to remove the duplicates. So here, earlier, in the third row and fourth row is deleted. You can see here 0, 1, 2 is there, fourth row and third row is deleted. You can see here third row, no, 0, 1, 2, 3. So here this is duplicated, right? So this is kept and this is deleted. And here 2.5, this is also 2.5. So this 2.5 is kept and this 2.5 is deleted. So that's why this two rows are get deleted. So you can see, likewise, if you go through here 7, 8, 9 columns are deleted. Likewise, you can see many rows are deleted. So that help us to know that which are all having the duplicate values in this particular column, that are all get deleted. Like that, we can also delete. Next is, I'm not going to particularly say about a particular column. I'm going to say wherever there is a duplicate value, you delete it, which means full row. Okay, I'm going to say drop the duplicates that is common for all the columns. If it is same, then delete it. So for that, I'm going to say, see here, in as I said earlier, we can see this two rows. These two rows are completely duplicated. All values are same. So this values also we can delete it. Okay. So first, that's why I'm going to keep. I'm not going to particularly here. I'm going to say any column. So it will delete the complete row. Complete row. So here I'm going to say again keep the first value. After that, if I see any of that particular duplicated row, you remove the complete row. So and then I am also saying here in place true, so that the changes which I make here will be reflected in the original data frame. So if I run it and if I now see the shape, now you can see there is only 22 rows are there. Earlier, if you see here, there are 24 rows are available. After I remove the rows which are all duplicated, then you can see there is only 22 rows. 2 rows are get deleted, because you can see this row is duplicated, and also you can see this row is also completely, this 2 row is also completely duplicated. So this row and this row is get deleted. So 2 rows are get deleted. And the next one is we also can do the renaming the column. So here, if you see in our data set, there is a column called year build. So it is set here as YR underscore build. So why I'm going to replace or rename it as completely as YEAR, year build. So for that, we have a function called rename. So this data frame object dot rename, and here I'm going to say the column I'm going to rename. If I want to rename the index value of a row, here you have to give index. Now we are going to rename the column name. So I'm going to say the property name as columns, and which name I want to rename year. YR built I want to rename as year built. So then I'm going to say do the changes and update it in the original data frame. So I gave in place as true. So now if I run it, and if I see my original data set, earlier it was like YR build, now it is renamed to year build. So rename help us to rename the particular column name also. Okay, now we can also see we are going to now what we are going to do the next is we are going to drop the null values or the missing values available in our data set. If you see in our data set, there are many missing values. So here there is a missing value, here there is a missing value, here there is a missing value, here there is a missing value. So one way of handling this missing value is we can able to drop those missing values. So to do that, we have a function called drop NA. So drop NA will help us to remove wherever there is a missing value, to help us to remove it. Here, this time we gave the access as 0, which means we are going to say remove those particular row completely, and then do the updation in the original data frame also. So now if we run it, and if we check the shape, it is 16. Earlier it was 22. After I remove all the null value rows, we have only 16 rows available, and you can also see. So these are the only 16 rows now available in our data set. Another way to handle this null value is that we can able to fill it also, and you can fill it by taking the mean value, median value, and many other functions, algorithms also there to fill those null values. We can also do that. So we can handle the missing values also. The next thing is we are going to measure the central tendency. This will all help us to understand how the data are distributed, how the data are having different values. So the properties will help us to know all those things. So in that category, measuring the central tendency is also very important. So central tendency is explain us about the mean, median, and the mode value. We all know what is mean. It is the average value. Median means when we arrange our particular data in ascending and descending order, the middle value is the mean value. And mode value means the most commonly occurring data is the mode value. So here from our data set, if you see here, I'm going to find all this for this particular feature called floor. I'm going to find what is the mean value, median value, and the mode value of this particular feature floor. So for that, I have said this from the data frame. I'm going to say the column name. For that, I'm finding what is the mean value. So it is 1.4. That is the average value. Because if you see here, all the values are around 1.5, 1 and 2, so 2.5. I think 2.5 is the maximum value and 1 is the minimum value. So if we take the average of, we will be getting 1.4. And then the median value. So if we sort all this value, and if you see the middle value, we'll get 1.25, and the mode value will help us to know the most frequently occurring data. So if you see the most frequently occurring data is 1, so we got that as. So this is what the central tendency, measuring the central tendency. The next one is variability. So what is variability means? It is the amount of variation available in our data set. Okay, so how can we find this variation is with the help of variance and the standard deviation. So for that purpose, let us also find what is the minimum value, what is the maximum value available in our data set. For this, we are going to take the feature floor. For this feature floor, what is the minimum value? We can know what is the maximum value. So the minimum value as we saw is 1, and what is the maximum value we saw is 2.5. So if you see here, there is also a value called 2.5. So that is a maximum value. And then we can also find the range from which we have the value. So to find that, we can subtract the minimum value from the maximum value. So that will help us to know the range. And next we can able to find the variation of the data. We are going to do only on particular feature called floor. Okay, so if you want to find the variance, we can use the function var. That will help us to find the variance. And what is standard deviation? So standard deviation is 0.53. So the square root of the variance help us to find the standard deviation. Using this point, we can able to find the variations in the particular feature flow. And the next one is IQR. IQR in the sense interquartile range. What does this interquartile range means? So our data generally can be represented in the form of this way. We can divide our data into 4 equal groups. So the first 25 part of the data and the remaining 75 part of the data is separated by this first quartile. And what is Q2, or we can also say it as median, that is the 50-50, that is 50% of the data, that is a median. No, median value is found by quartile 2, and the quartile 3 means the first 75% of the data and the second 25 part of the data is separated using this third quartile. So it represents how well our data are distributed. So where our data is having, whether our data is near to this median, that is Q2, or where our data is distributed only in the first quartile or in the third quartile, like that we can able to analyze our data. So for that we can use this interquartile range. So if you want to find this interquartile range, which means the values which is around this median, we can able to find it by subtracting the Q1 from Q3. So that will help us to find the IQR values. So IQR represents the spread of middle 50% of data. So this middle 50% of data is IQR. So the difference between the upper quartile, that is Q3, and the lower quartile Q1 is IQR. So this quartile means we know this are all 4 equal part of the quartile, and this is the first quartile and second quartile and third quartile. So now let us find IQR. So as I said, it is the difference between quartile 3 with quartile 1. So 75% quartile minus 25% quartile. So let us find this quartile for our feature floor. So here for the feature floor, I am going to first find this Q1. Q1 means what? First 25%, right? So I'm going to say quartile of 0.25. So that is Q1. What is Q3? The first 75% of the data, right? Where it is distributed. So I say this floor dot quartile of 0.75. So now we found what is Q1, this Q1 and Q3. Now if I want to find IQR, I will subtract Q1 from this Q3. So IQR equal to Q3 minus Q1, which help us to find this IQR, that is 1. Okay, so this will help us to know where our data is distributed. Is it distributed around the median, or in the first 25%, or in the rest 75%? Like that, distribution can be found using this IQR value. And the next one is Z-score value. So this will help us to determine the unusual or usual data points in the distribution. So for example, what is unusual data means? For example, if I want to say whether the school students will be ranging the age from 2.5 to 17. But if I say the age is 23 or 30 or 40, this is the unusual data for a school student's age. So whenever so this we also called as outliers. So Z-score will also help us to find this outliers, which is the unusual data point for a particular feature. So usually this Z-score value will be ranging from -3 to 3. So if the value is between this, we can say this is the proper, the data points are within the limit or in the proper usual distribution. If the value go beyond less than -3 or greater than 3, then we can identify this is an unusual point, that we can call it as outliers. So using this Z-score, we can able to find this outliers. So how will you find this outlier using Z-score? Is the formula is the one of the we have a huge amount of or many data point in a population. So we'll be taking one by one value, that is x, subtracted from that we are going to subtract the mean of the full feature divided by standard deviation. So this will help us to find the set score. And this x means, as I said, it is a single data value from our feature. So to do this, find the set score, we are going to use the module or the library called SciPy, and from there we are going to use the module stats. So we are going to use the allied stats to use this. So I'm going to say to find set score, I'm using the stats dot set score function, which is already available there, where I'm going to do to which feature I'm going to find this set score. So I'm going to say I'm going to find the set score for flows, and then we can able to see it. So here you can see all the values are within this range. So there is no outliers for this floor as of now. So the set score help us to find that. The next thing is correlation map or correlation map. Also, we have another map called heat map. We are going to see that. First one is, let us see about the correlation map. So what is the purpose of this correlation map is, it will help us to find the relationship between the variables. So for example, let us find all the relation. So if you see in our data frame or in the data set, we have this many features. So we can able to find the relationship between these features. So if you find the relation, we can able to find, is it positively correlated or negatively correlated. So here you can see the correlation. What is the meaning? How the one variable is related with another variable. So if you will see with price and price, bedroom with bedroom, bathroom with bathroom, living square feet of the living room or square feet of the lot, all are in the diagonal, no, all are one, because they are highly related to one another. And but if you see, if the value is positive value, for example, price and the square feet of the living room, it is positively correlated. The relationship is positive, because as the square feet increases, the price will also increase. And if you have a negative value, it says it is negatively correlated. So if one value increases, the other value will be decreasing. So that is negative correlation. So if the value is near to 1, then it is, we can say it is positively correlated. If the value is near to 0, it is negatively correlated. So so we can know how well one variable is having the relationship with another one. So that is the purpose of correlation. Okay, and so this shows the complete correlation between each and every features available in the data frame. And we can also find the correlation using this can also be represented using the heat map also. Here if you see, this is the heat map, which is data visualization method using heat map, which is available in a library called Zbond. Using this alias SNS dot heat map, we are going to send this correlation variable to say input, and we are going to find the correlation between each and every feature available here. And also in the x-axis is the this value, x-axis value, and in the y-axis value, we are going to say the columns available in this. What is in COR? We have taken the complete correlation and it's kept in the object COR. From that, I'm going to take all the columns and kept here in the y-ticks and in the x-ticks. Okay, and so this shows, and here you can see the C map, color map. What does this color map says? This light colors is highly correlated, and this dark color is negatively correlated. There is no proper relationship. So you can see this, no, diagonal values are highly correlated, because price with price, and you can see bedroom with bedroom is highly correlated. And the light color, you can see which are all light color. This is a light color. So here you can see the square feet and bedrooms is highly correlated. And what else we can see? The price and the square feet is also highly correlated. But these features are not highly correlated. What are they? Square feet and renovation. These are all not highly correlated. So this dark color says that if you want to know the values of each and every cell, we have another features called annotate. So if you say annotate as true, we will also get the values in it. So you can see for each and every cell, the values are also available. And also we have another feature called line width. So if you say the line width, that will also give a proper spacing between the cells. So here you can see a clear spacing between the cells. So these are the another features. If you don't want this CMAP also, we can also say that CMAP equal to false. So that will not display this line, okay? Or we can say, does it say? So if you don't want, you can make it as false so that it will not CMAP, that particular line will not be displayed. So CMAP means that the color map. So that will not be displayed. And so these are the different ways we can able to show the relationship between each and every values. Okay, so let it be. And then the next is finding the correlation of a particular column. So here we found the correlation between each and all the features in the data frame. So if you want to find the correlation between particular columns alone, then I'm going to take it. In the object T, I'm going to take only the features, price, bedroom, square feet living and year built. So that alone I'm going to take in this object, and for that earlier we used this complete data frame, and for that we found the correlation. Here I'm going to take those particular columns alone and I'm going to find the correlation. So here you can see only for the price, bedroom, square living and year bill we are going to find the correlation. So if the value is like this, bedroom and the living room is highly correlated, it has the relationship, but you can see price and the year built is negative correlated. So if one value increase, if other value also increase, means it is positive correlation. If one value increase, other value decrease, means it is a negative correlation. So for the same thing, we can also make the CMAP as well. And if you don't give not as true, this value will not be coming. Okay, it will be giving this, but using the CMAP color map, we can see this light colors are highly correlated and the dark colors are negatively correlated. Okay, so the next one is outliers. As I already see in our data set, there is no outliers. So we can also include outliers, and then earlier if you see here, there is no outliers, right? So we are going to include some outliers and see how it is performing. So I'm going to include some 3 rows, and in the floors I'm going to give some higher values which is out of the range or unusual value. If you see in this data frame, here our values range from 1 to 2.5, but this time I'm going to insert 12, 13, 17. So just I created a dictionary where I gave values of this different features, and I'm going to append it inside our data frame. So let us say this as so in the data frame, first I'm going to append this first one, first dictionary, and I want to include it in the last, not in the beginning. So I'm saying ignore index, true. So all the 3 data frames are inserted, and then we will check our data frame. So if you see in the data frame, in the last, we can see the floor values 12, 13, 17. These 3 rows are get inserted because of this. After we insert, we can also so and here you see some of the values I have not given inside. Some of the values, if you check with other values, like if you see here, year built, year renovated and all, I have not included. So automatically for those value, null values are inserted. So to handle this, already I told you, we can also fill the null values using fill and a. Another one is I'm going to replace this null value using replace function. This null values are replaced with some values here. I directly gave a 765. We can find some mean value or median value and we can replace it. And the changes which I make, I'm going to update in this place itself. And then I'm going to run it. And let us see, all the null values are now filled with 765. Now we are going to display using this cat plot that will help us to find the outliers. So here the x value for this x value, the floor column, I'm going to display the box plot, and the data is our original data frame. And if we run, you can see these are the outliers. So this categorical plot help us to find the outliers. We know this last three value which we inserted are outliers, unusual values. So what can we do now? If you see this mean, variance, and the standard deviation of this flow, we can see the value got highly increased. So this through this we can easily understand that our this outliers is even affecting the mean, median, and the standard deviation. If you see our older standard deviation value, it is very less. See here, it is 0.2, 0.5. But after we add this outliers, it is very much impacted. Now we are going to find this IQR value as before, and then we are going to, now what we are going to do is in the set score we said we are going to find the lower bound and the upper bound, which are all inside this lower bound and upper bound. So that is what is lower bound, Q1, quartile 1 and quartile 3, and using that we are going to find the lower bound and upper bound, which are all within this bound. We are going to keep it. Others we are going to remove it. So here I am going to find the lower bound, that is quartile 1 minus 1.5 into IQR. We already found. Similarly, quartile 3 plus 1.5 into IQR is the upper bound. So we are displaying it, and we are saying the data frame floor, that column which are greater than the lower bound and less than upper bound, we are going to take those rows alone, and we are going to keep it in a new data frame, this one. So if you see, there are only 16 columns within this range. And if you display this, you can find those columns who are only within this range. Tail means the last 5 rows. So now we can see after we take in this data frame, for this new data frame with inside the lower bound and upper bound, now if I plot the categorical plot, the box plot, there is no outliers because we are taking only the row within the lower bound and the upper bound. And now you can also see the set score also within this range. If it is out of the range, we can able to remove it. So I'm going to filter the set score greater than 3. We can filter it. And since we don't have any value greater than 3, right? So if I take only the set score value who is greater than 3, and if I found it, there is no rows which is going outside the upper bound because all the values are within this range. Sometimes the value may be, because we took only the values which are within this condition, right? Which is less than this, and this greater than a lower bound and less than the upper bound. So this is how we can able to handle our outliers, and we can able to handle and give a proper value, have a proper data set, and we can send this as an input to our machine learning algorithm, which help us to do proper predictions, finding a proper patterns, and do proper decisions through the machine learning algorithm. So if you give a wrong data, it will give you the wrong decision. So once after doing exploratory data analysis by removing the outliers and the unnecessary columns, filling the null values, all this help us to do handle our data. And after we do proper handling of the data and we give to the machine learning algorithm or any other data analyzing techniques, we will get proper decisions also, so that we can get a better predictions. Hope you have understand about this EDA. Thank you.